value here, form the second order, and solve. So you will find NT. So once you find NT, that's the step 1, right? Step 2 is, once you find NT will be, say NT is, let's say it's 3t squared plus 2t. Let's just assume that's it. I haven't solved it. Let's assume that's it, right? So what you will do is you will say t. For question B, you say 0, you could do 2, you could even do 5, 10, 15, 20, 24. You don't have to do much. Then you will say NT. Then this is 3t squared. NT is equals to 3t squared plus 2t. Then you will start with 3 times 0 squared plus 2 times 0. 3 times 5 squared plus 2 times 5. Does that make sense? Then you can do 3 times 10 squared plus 2 times 10. Then you just plot NT versus T here like this. You plot it. That's question B. That's what you should do. Right? If you get a question like that, that's how you do it. Question 2 is the same thing, except that you're just looking for the general solution in question 2. Question 1 and question 2, they're the same. Question. If you don't understand, I can go over every time. Plus Q of T, Y is 0. It says where P and Q are continuous open interval I. Then the Wronskian of y1 and y2 is C exponential minus integral P of T dt. I think I derived this before, but I made one major mistake, which I want to correct. So let's start with, you're given these differential equations, right? And then we want to derive the Wronskian of y1 and y2. So we can say, let the first equation in terms of y1 be y1 prime prime plus p of t y prime plus q of t y is 0, right? And we can say, let this one y2 prime prime plus p of t y, this is y1, plus y2 prime plus q of t y2 is 0. I'm going to solve it up to the mistake I made, right? So what I did was say, am I missing something? No. I said multiply this by y2, multiply this by y1, right? That's what I said. So if you do that, this becomes y1 prime prime, y2, right? The reason why I'm multiplying it is I want to try and get rid of this. So I need to flip y2 and y1 here. This becomes p of t y1 prime y2, right? Plus q of t y1 y2 is 0. If I make any mistake again, please correct me. Then if you multiply by y1, this becomes y2 prime prime y1, right? Plus p of t y2 prime y1 plus q of t y1 y2 is 0. So what we do is we can call this equation 1, we can call this equation 2. So let's just do equation 1 minus 2. Let's just say equation 1 minus 2. If we do that, it means everything here minus everything here minus everything here, and this minus this. We could do that. So that becomes y1 prime prime y2 minus y2 prime prime y1. We can put a bracket here like this to make it easier, right? Plus p of t is in both, so we can just bring p of t out and say, we could say y1 prime y2 minus y2 prime y1 like this, right? If you see it, minus this guy is the same as this guy, right? Because it's just q of t y1 y2, q of t y1 y2. So it can go. So we can say it's equals to 0 like this, because that can go. Yeah. So we said when you have two solutions, y1 and y2, the Wronskian is the determinant of y1, y2, like this, and y1 prime, y2 prime. Remember, that's what the Wronskian is. Wronskian, W, is, who speaks Russian here? Anyone? Would be y1, y2 prime minus y2, y1 prime. I used to live in Estonia. I lived there for a year, and they speak Russian a lot. There are a lot of Russian there. So I was learning Russian, and I had a Belarus roommate. But unfortunately, it was too hard for me. I stopped halfway. But anyways, this name looks like a Russian name. I would have loved someone that can speak Russian to pronounce it. Anyone? Yeah. There is a unique way to pronounce it. So the mistake I made was W prime should be like this. It should still be Y1, Y2. Instead of this, it should be Y prime prime, Y1 prime prime, Y2 prime prime. This was the error here. So W prime should be Y1, Y2 prime prime minus Y2, Y1 prime prime. Yeah. Because if this goes prime, we still maintain the original function and make this prime prime. That was how I got it from. Now, look at something. Everything here, compare it to what is here. If you compare it, here is Y2 prime Y1, Y2 Y1 prime. Here is Y1 prime Y2, which is this guy, and this is this guy. So this can be plus PT negative W. It's just flipping it, because if this is this, our negative W is the same thing as Y2 Y1 prime minus Y1 Y2 prime, which is this guy. Yes, Y2 Y1 prime. Okay, if you look at this guy here now, the same thing here. This guy is Y2 prime prime Y1, which is this Y2 prime prime Y1. So this one will be minus Wronskian prime. That's what we have. I'll stop here and let you look at it and let me know if there's any question. We would use this formula a lot. That's why it's very important to learn how to derive it. We'll use it. See, like this is 0. Okay. So do you agree with me that this is the same thing as saying W prime like this is equals to negative P of T W? It's just taking this to the other side. So if we rearrange, we have W prime over W is negative P of T. So we integrate it, right? So if you apply integral here and you apply the integral here, this becomes ln omega like this, ln W. Am I right? Plus, we can call the constant A is integral negative P of T like this, dt. So if we take this integral A to this side, we have ln W would be integral minus P of T dt minus A. Right? Remember, A is a constant. We could just say let another constant B is negative A because it's a constant. So we could say that. So if we do that, this becomes our ln of Wronskian is integral negative P of T dt plus B. So we're looking for this. So we take exponential of both sides. And that becomes exponential ln of W is exponential integral negative P of T dt multiplied by exponential B. Because exponential, that's exponential, we give this plus this. And we could say let C for cat, be exponential B. They are constant. So, and exponential ln W is W becomes C. Exponential integral negative P of T dt. So this formula, please skip it. That's called Abel's theorem. It's very, very important when you're dealing with second order. Theorem 1 is saying, forget all the math or all the long discussion. What it's saying is, if there are two solutions, y1 and y2, right? And then you can take constant c1 to be equivalent to y1 and c2 to be equivalent to y2. And then it says that the general solution could follow the form y is c1 y1 plus c2 y2. That is exactly what it's saying. That's what the theorem is telling. And that's what we've been using. For example, we said that if there is two different roots, R1 and R2, our general solution is C1y1 plus C2r2. That is exactly what the theorem is saying. And the second theorem here is saying that if the Wronskian is equals to 0, then these two are not solutions to the differential equation. For these two to be solutions, the Wronskian would not be equals to 0. So that's what this theorem is saying. So let me repeat these two theorems on page 1. The first theorem is saying that if you have two values, y1 and y2, and the equivalent constant to y1 is c1 and c2, the solutions to the differential equations could be y is c1y1 plus c2y2. And this solution is correct only if the Wronskian of y1 and y2 is not equals to 0. If the Wronskian value is equals to 0, then this solution does not satisfy that differential equation. So I can give you two values and say, are these two values solution to a differential equation? The only way you can know is you calculate the Wronskian of those two values. If that W value is 0, they are not solution. If it's non-zero, they are solution. And that's what this two theorem is telling you. So let's do one example. If you go to page 2, question 1 on page 2 here. Question 1 says that, question 1 on page 2 says that being biased during the dodgeball, I know I was the referee, T equals to ER1T and Y2T is ER2T. This says there are two solutions. We want to, it says you show that they form a fundamental set of solutions. How do we show that these two form a fundamental set of solutions? Does anyone know? And that's what the theorem is telling us. Because now we have y1 and y2. We have value of y1, value of y2. And we're told that r1 is not equal to r2. So the only way these two can be a solution to a differential equation if the Wronskian value is not equal to 0. Because the Wronskian is used to test if these two values are actual solution to a differential equation. So we find W and see if it equals to 0. If it equals to 0, according to the second theorem, remember the second theorem says that if W is equals to 0, then they are not fundamental solutions to a differential equation. If W is not equals to 0, then there are solutions. So all we need to do is find the value, and the way we do that is we just say the Wronskian is the determinant of our y1 is ER1T, our y2 is ER2T. Our y1 prime will be R1 ER1T. Is that correct? When you differentiate that, and this would be R2 ER2T. So if you get a question like this, and I ask you to show if there are solutions to a differential equation, what I'm asking you to calculate is the Wronskian value. And the Wronskian is the determinant, which is always this one. So Wronskian will be E R1T multiplied by R2 E R2T minus E R2T multiplied by R1 E R1T. So this becomes R2 E into bracket R1T plus R2T, because you can add them together, right? Question. Everyone is looking at me as if I've done something wrong. Tell me now. All I did was say, this multiplied by this is saying take one, then you add this. That's correct, right?
Yeah.
Okay. Minus the same thing, R1E, R2T plus R1T. So, this becomes R2E, T can go out, R1 plus R2, minus R1E, T can go out, R1 plus R2. Okay? So, if we bring this here, these two guys are the same. They look the same. I want to believe they are the same, right? So, since they are the same, that becomes, it becomes E R1 plus R2T, then R2 minus R1. Right? Can someone tell me why this value can never be 0? Yes?
Because R2 doesn't equal R1.
Yes, exactly, because the question told us that R1 is not equal to R2. So the value can never be 0. So the Royskian can never be 0. So it means these two are fundamental solutions to a differential equation. Thank you for that. So I would let you do question 2. Do question 2 yourself, still on page 2. Do question 2 and tell me what you got. T half, right? T minus 1. So when you differentiate this, what do you get? That's 1 over 2 T minus 1 over 2, right?
Yes.
This one becomes minus T minus 2. Is that it? So this guy goes like this. So that becomes T half multiplied by T minus 2 minus, this becomes T minus 1 multiplied by 1 over 2T minus half. I'm going to jump step here because we are all smart. So this becomes T minus 1, right? Because these two cancels out this. Then minus this becomes...
You add them.
What am I doing?
You add them.
You add them.
Say that again.
You add them.
I add, this multiplied by this is add them. Yes, you're right. Yeah, you can see. 1 over 2 minus 2 over 1. Minus T minus 1 minus 1 over 2. Is this correct now? Yes.
I think there's a negative in front of the first two.
Yeah, this is minus here.
No, when,
Wait, this one?
yeah, because in the determinant matrix, the bottom.
Yes, sir, the second term should be minus.
Ah! Wait, let's start again. Do you agree this is correct?
Sir, no.
What am I missing?
Sir, the second term should be minus.
Minus T minus 2.
I give up. Is this correct? Is this correct?
Yeah.
I'm trying to make it simpler for people to know that before you can multiply to add this, they have to be the same. That's why. Now, please tell me if I make any more error. Let's bring this 1 over 2 out. 1 over 2 T minus 1 over 2. Okay. This will be T 1 over 2 minus 2, right? Is that correct now?
Yeah.
Minus, this would be, let's put this guy here. T minus 1 over 2. What's 1 over 2 minus 2? That's 1 minus 4, right? That's minus 3. That will be minus 1. This will be minus T minus 3 over 2. Then minus 1 over 2. This would be 2 plus 1, 3 over 2. T minus 3 over 2. That is interesting. If you add these two, you will get negative 3 over 2. So that's correct. That will be negative 3 over 2, T minus 3 over 2. Please do not be like me and make mistakes in the exam. Right? I beg you. Okay, let's say it's f of x. That's what we said. And then we said, if f of x is 0, what type of differential equation is this? Anyone? If f of x is 0, what type? Yes?
Homogeneous.
Homogeneous, thank you. Homo. So, and then for this homogeneous, what we said is, you assume it's a quadratic equation in the form of r squared plus say ar plus c is equals to 0. And we said you could have, if you have two different roots, when let's say this is ar squared plus br plus c, if b squared is greater than 4ac, our solution is c1 y1 plus c2 y2. Is that correct? We also say b squared is equals to 4ac. Our solution y will be c1 plus c2x exponential rx. That's what we said. And we said if b squared is less than 4ac, we have complex roots. Complex roots in the form of alpha plus or minus beta x. And we said our y is exponential alpha x a c1 cos beta x plus c2 sin beta x. So there are 3 case studies, right? Now, if our fx, we go back to this. If our fx is not equals to 0, it is called non-homogeneous. So how do we solve that? Because everyone we've been solving now is homogeneous based on any of these 3 case studies. Now, for non-homogeneous, there are several ways you can solve them. Undetermined coefficient. You could use the method of variation of parameters. And my favorite, you could use the Laplace transform, which we would get there. So the guy from math, he came to this class to observe last week. The question he asked me is, are they doing Laplace transform? I said, why do you ask that question? Because he says he had a chemical engineering friend in college, and all the guy did was talking about Laplace. Yeah, Laplace is very, very important in chemical engineering, especially for process control. So we'll get there. So one advice I always tell people that take this class is, after this class, download all notes and keep, especially the one on second order and Laplace. When you're doing your senior design or process control, I promise you, you come back to the notes. Save them because it might be gone. Right? So today we'll start with this method. Hopefully next week we can cover this. If we have time, we'll do this. Otherwise, after spring. I try to make it easier if you flip to homogeneous. You assume homogeneous first, and you solve. That's the first method, right? So you solve it normal, assuming homogeneous. Then method 2 is find yp. I'll give you how to find yp, I'll tell you. Then method 3 is your solution is y homogeneous plus yp, right? So the value of yp you will assume could take different form based on f of x, So the function, this f of x, will determine what value your yp will take. And if you go to page 3 of your worksheet, there is a table I gave you. So that table will help you. I'll do examples, you see. So that table is going to help you. If you go to page 3, you will see a table. The table says type of fx and the trial solution you would use. That table says something like this on page 3. So if your fx is exponential kx, you're going to use a exponential kx. If your fx is a polynomial, say x raised to the power n, it becomes a raised to the power n, x raised to the power n plus a n minus 1, x raised to the power n minus 1, like that. I will do examples for all this, don't worry. If your fx is cos kx or sin kx here, it's going to be a cos kx plus b sin kx. Those are the 3 most important functions you will do. Everyone will do in this class will cover this. So, question before we do an example. Page 4, question 1 says that you have y prime prime minus 3y prime minus 4y is 3 exponential 2x. We know that this is second order, right? We also know that this is non-homogeneous because you can see it's not equals to 0. It has a value here. So, it's second order, it is non-homogeneous. So that means we follow these 3 steps. First, we assume it's homogeneous, we solve first, right? Then the second one, we find yp. And the value we assume for yp will be based on this table. Right? So the first step is let's solve homogeneous. So I want you all to solve this homogeneous and tell me the answer. Solve as homogeneous. So you do that yourself and tell me the answer. So you say y prime prime minus 3y minus 4y is 0. So solve it as homogeneous first. And tell me what you get when you solve it. I'll wait for you. This y prime prime has r squared, right? Then minus this becomes 3r, then this is minus 4 is 0. So all you need to do is find two numbers, whose product is 4 and whose difference on addition is minus 3. And that is minus 4 plus 1. So that becomes r squared minus 4r plus r minus 4 is 0. One advice, if you do not remember how to solve quadratic equation, please bring a calculator on Thursday that can solve quadratic equation. You don't have to show me this working. You could just jump from here to the answer, it's fine. Right? If you feel like quadratic equation will waste your time, you can bring a calculator, it's allowed. There are so many calculators that can solve quadratic equation. So be prepared. So that's r minus 4 plus 1, r minus 4 is 0. So our r becomes 4 or minus 1. Apologies for jumping step. So if you do it, these are two solutions. So this is correct. Right? Okay, now the second step is our numbers, we need to find yp. So we say our solution y is c1 exponential 4x plus c2 exponential minus s plus yp. This is our solution. Yp is the non-homogeneous term. So we just need to find yp. So remember this table, if it's exponential kx, our yp will be what? A exponential kx. In this case, our ffx is this guy. Is 3 exponential 2x. If our f of x is 3 exponential 2x, so what that means is that our yp would be a exponential 2x. Because in this case, it's exponential kx. So, which is exponential 2x. So, it's going to be a exponential kx. That's our yp. If it was x raised to the power n, we'll do another example. It's going to be like this. We'll do a series of examples. So what you need to do is you need to find yp prime and yp prime prime and plug it into this equation here. That's what you need to do. So our yp prime becomes 2a exponential 2x. Yes?
Why, when you do yp, do you get rid of the coefficient in front of f of x?
3.
Yeah, why do you get rid of it?
Because it's a constant term, we don't consider it. We only consider exponential 3x and say a exponential 3x. We're only concerned about that x term, exponential x term, yes.
Okay.
So, to make it easier, I could put m here and say m is any constant. It doesn't matter. Okay, that would solve the problem. That's a good question though. Yp prime prime, you would see that we will still use that 3 later on. I'll show you where we use it. Becomes 4a exponential 2x. Question before I continue. Okay, I apologize, I'm solving backward. All these values, we plug it inside here and see. So from y prime prime is 4a exponential 2x, we put it here, it becomes 4a exponential 2x minus 3y prime is this guy. 3 times 2, that's y prime is 2a exponential 2x minus 4y, which is a exponential 2x. Remember, this says is equals to 3 exponential 2x. Remember, that's what it says. We can say it's 3 exponential 2x from here. So it becomes 4a exponential 2x. This becomes minus 6a exponential 2x minus 4a exponential 2x is 3 exponential 2x. Right? So if you bring this guy exponential 2x out, it becomes 4a minus 6a, right? Am I missing something? Minus 4a is 3 exponential 2x. Okay, this guy could get rid of this guy. If I've missed something, let me know. So 4a minus 6a is minus 2a. Minus 2a minus 4a is minus 6a, right? Yeah, so we have minus 6a is 3, a is minus 1 over 2. If a is minus 1 over 2, our y of p is a exponential 3x. That would be a is minus 1 over 2 exponential 3x. So our solution is this guy. But we'll just put our y of p there. So our solution, our general solution, which is y is c1 exponential 4x plus c2 exponential minus x plus y of p. So our solution becomes c1 exponential 4x plus c2 exponential minus x minus 1 over 2 exponential 3x. So this is our solution. Mara, question. The same as this guy. Am I correct? Great. So now, our y of p is supposed to be a exponential minus x. But here is a condition. The condition is if this exponential appears in one of these solutions, exponential minus x appears in one of these solutions. If it ever appears in one of these solutions, we won't be able to solve it. So instead, we say y of p is ax exponential minus x. That's the condition. Because this guy appears in one of these solutions. If the exponential ever appears in one of these solutions, we add an x there to help cancel it out. So before you assume, you need to check if the exponential is in one of the solutions. Now that we have it this way now, we could say yp prime is, those of you that have done it, I'll let you complete it from here and tell me the answer. I'll let you solve it because you're meant to solve it anyways. So keep solving now. A exponential minus x. Is that what you got? Here. So let's do yp prime prime. Yp prime prime is, let's start with this one. If you differentiate this, you just get the same thing. Yeah, you get the same thing, right? Is that what you got, or you get exponential minus x? Is that correct? So let's do this. Again, we do the same thing, plus you keep negative ax constant. You differentiate this, you will get negative exponential minus x, right? Then plus, you keep exponential minus x constant. If you differentiate negative ax, you get negative a. I have a feeling I've missed something. I don't know what. That would be a exponential x plus this becomes ax exponential minus x, right? Minus a exponential minus x. Yes?
I think it's a negative on the first.
Here.
The first one.
The first one. What am I missing?
Like when you check the derivative, I think it should be like on the line down.
This one.
Yeah, one more down. I think there should be a negative in front of it.
No. This one, yes. Because this has a negative. I knew I was missing something. Thank you. Well, so this has negative. Am I missing any other thing? Yes.
On the same term, it should be e to the negative x.
There is no a there. The a goes. Are you sure?
No, the a is still there, but it should be e to the negative x, not e to the x.
I keep missing negative, and this is annoying me. Did I miss any other thing? Here. It's correct now, right? Please tell me I did not make mistake again. As you can see, I make mistakes too. So when you're solving in the exam, be very, very careful. Go over it and go over it. I do that too. Sometimes the tension is always there. And I don't penalize you sometimes. If I know that you know it, it's just unfortunate. But here, so that becomes negative a exponential negative x. That's not good. I'm missing something. Does anyone know what I'm missing? So that becomes minus 2a exponential negative x plus a exponential negative x. Please put up your hand if you get this as y prime and if you got this as this thing. Is that what you got? No? Yes. Plus 4y is 2e negative x. So y prime prime is negative 2a exponential negative x plus ax exponential negative x. Then minus 3 multiplied by y prime is negative ax exponential negative x plus a exponential negative x. Okay, I want to be sure I don't miss anything here now. Minus 4y, our y is ax exponential negative x. So that gives, let's put everything together. That gives negative 2a exponential negative x like this, plus ax exponential negative x. This gives plus 3ax exponential negative x minus 3a exponential negative x like this, because this minus 3, yeah, this minus and minus is plus. Then minus 4ax exponential negative x. Let's start seeing which cancels out. Amy, you are the one at the experiment. Can you see here? Do I need to move over there?
No, you're fine.
Are you sure? Okay, so which cancel out? This is ax exponential negative x. 3ax exponential negative x. This becomes 4ax exponential negative x, right? Minus 4ax exponential negative x. So that cancels out. These three cancels out. Right. You have minus 2a exponential negative a minus 3a exponential negative x. That's minus 5. So you have minus 5a exponential negative x would be equals to, then you equate it to this guy here, 2e negative x. So a becomes, because this can cancel out this, a becomes minus 2 over 5. If that's our a, this question is very stressful to solve. If that's our a, our yp becomes minus 2 over 5x exponential negative x. So you can then put it here. Yeah, I'll give you a similar question in your